Okay, in this question, we have to investigate the speed, the frequency, and the wavelength as the wave passes from region 1 to region 2. So the best way to put all the data together is through a table. Okay, we have region 1, region 2, we have the speed, the frequency, and the wavelength. Okay, the speed is given as 0.2 meter per second in region 1, and the wavelength is 3 cm. So we change this to meter, it will become 0.03 meter. And using the formula, V is equal to F lambda, F is equal to V over lambda, we should calculate the frequency as 0.2 divided by 0.03. This will give us 6.67 Hertz. And because the frequency of the wave is the same, it follows the frequency of the source. The frequency will not change even if the wave has moved into another region of different depth. So the frequency at region 2 will still be 6.67 Hertz, and we are given that the wavelength at region 2 is 1.5 cm. So convert it to meter, it should become 0.015 meter, and the speed at region 2 can be calculated by this formula. V is equal to F lambda, so it will be 6.67 multiplied by 0.015. That will give us 0.10 meter per second. So the answer should be A. Okay, the diagram here shows a periscope. So since the object is here, the light ray will hit the first mirror in this direction. Then after that, it will undergo a first reflection to hit the second mirror, and it undergoes a second reflection to reach the eye. So since this light ray enters the eye and the brain does not know that the light ray has taken two reflections. So what the eye will do is that the eye will trace back and form a virtual image at D with the help of the brain. And that's why we say that the eye and the brain is tricked by the bending of the light. And how far it will trace back, right? It depends on the distance of the light ray that it has to travel to reach the eye. So this distance plus this distance plus this distance will be the total distance that the eye will track back, and hence the virtual image is formed at D. Okay, in this question we have a light ray that is traveling from glass to air at an angle of incidence of 40 degrees. So we can draw a simple diagram here. Glass and air with the incident ray hitting the contact surface at an angle of 40 degrees. Okay, we are given that the critical angle is 43 degrees. So the angle of incidence being 40, it is less than the critical angle. Hence, total internal reflection will not occur. In fact, only normal refraction will occur. So since it's traveling from an optically denser medium to a less dense medium, the light ray will be refracted away from the normal, and at the same time there is a weak reflected ray that will be reflected back into the glass surface. Hence the answer should be B. It is partly reflected back into the glass and partly refracted into the air. So answer B. Okay, in this question, we have an arc of the circle represented by PQ, and the center of the circle is at O here. So if we were to draw a line from the center to the arc, it is going to strike the arc at 90 degrees. Okay, because of the angle property that radius is perpendicular to tangent. Okay, so that gives us the angle of incidence as 0 degrees. So there shouldn't be any refraction of the ray. The ray should just go straight into the other medium. So that only left us with option B and option C, which go through the surface unrefracted. Okay, then since this is a diverging lens, as the ray travel out back into the air again, it should diverge outwards, which is shown in option C. So this is the correct answer. And why is B wrong is because the light ray is passing through the center of the lens. So by right, there should be no refraction at all. That means the ray should go straight. But B bends downwards, so it cannot be the answer. Okay, this question tests us on the application of the EM waves. So there is not much concept involved. What we need to do is just to memorize the applications of the 7 EM waves components. So infrared radiation, it is used as intruder alarm, and it's also used as a television controller, and it is used in a toaster to heat up the bread. For ultraviolet radiation, it is used in sunbathe as well as sterilization. For gamma ray, it is used in the treatment of cancer. So with this, only B is the correct answer for all 3 components of the EM waves.